Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 1, the 4th edition of RK Bali navigation book. In this particular lecture, we are going to solve questions from 61 to question number 70. Some very important questions. We will look at the theories, the concepts behind them, and how to solve numerical questions. So let's start with question number 61. Considering the maximum operational Mach number and the maximum operational speed (VMO), the captain of a pressurized aircraft begins his descent from a high flight level. In order to meet his scheduled time of arrival, he decides to use maximum ground speed at any time of the descent. He will be limited by MMO (maximum Mach number), by VMO in still air, initially by MMO, then by the VMO below a certain flight level. So remember, first VMO. So VMO is the maximum calibrated airspeed at which the loads imposed by dynamic pressure on aircraft is acceptable. That is VMO. Now what is calibrated airspeed? Calibrated airspeed is nothing but a measurement of dynamic pressure. Right? Your airspeed indicator measures dynamic pressure. That dynamic pressure is translated into indicated airspeed information, which is corrected for position error and represented as calibrated airspeed. So that is your calibrated airspeed. So now if you want to fly at a calibrated airspeed of, let's say, 100 knots, okay, at sea level, if you want to fly at 100 knots calibrated airspeed at sea level, you require, let's say, a dynamic pressure of 500. Now you go to higher altitudes. When you go to higher altitudes, let's say you go to 5,000 feet. Now at 5,000 feet, the atmospheric pressure is going to decrease. As you go to 5,000 feet, atmospheric pressure goes on decreasing. So the calibrated airspeed information shown to you by the airspeed indicator will also start decreasing in value. You may be flying at a constant true airspeed to that 5,000 feet altitude, but calibrated airspeed indication, which is nothing but an indirect indication of dynamic pressure, will automatically start decreasing. Why? Because the surrounding pressure at 5,000 feet at higher altitudes start decreasing. Right? So as you go to higher and higher altitudes, atmospheric pressure starts decreasing. So if pressure starts decreasing, the registration of pressure which is happening in the pressure instrument, that will also start decreasing, and accordingly you will get that output. You will get a lower output, lower input, lower output. So and you will get an indication of lower calibrated airspeed. So to prevent that from happening, in order to prevent an indication of lower calibrated airspeed from happening, what you will have to do is you will have to increase the true airspeed of your aircraft. So let's say you were initially flying at a constant true airspeed of 200 knots to a higher altitude. But what we experience is a reduction in calibrated airspeed. Now, in order to prevent that from happening, you will have to increase the forward speed of your aircraft, namely the true airspeed. Now, when you increase the true airspeed of your aircraft as you go to higher and higher altitudes, the dynamic pressure impacting your pitot tube will also increase. The true airspeed increases, the pressure at which air strikes the pitot tube and the dynamic pressure that it creates around it will also increase, and this increase in dynamic pressure will be registered as increase in calibrated airspeed. So this is a trick that you are playing. This is the compensation choice, right? So you increase your true airspeed deliberately to maintain your calibrated airspeed or to prevent it from falling in value. So if you want to fly at the same calibrated airspeed, you want to maintain the same calibrated airspeed indication of 100 knot in your airspeed indicator at 5,000 feet, what you will have to do is you will have to increase the true airspeed of your aircraft such that it creates additional impact pressure which will compensate for the lower static pressure existing at those high altitudes. So I'm writing here 600. Now dynamic pressure is 600 for a calibrated airspeed of 100 knots, right? So this is what happens. So as you go to higher and higher altitudes, in order to keep or maintain the same calibrated airspeed, the dynamic pressure acting on your aircraft will go on increasing. So if you want to go to now 8,000 feet, let's say, and to maintain same calibrated airspeed of 100 knots, you will have to further increase your true airspeed, because when you go to 8,000 feet, again the atmospheric pressure will decrease by a certain amount, by a higher value. So again, you will have to increase your true airspeed further, right? Accelerate more, and that will create additional dynamic pressure in addition to 600. So this will go on happening. So there will you will sooner or later you will reach a point. You will reach a point where you cannot accelerate further. You cannot accelerate further because loads imposed by dynamic pressure will be too high, will be too high to bear, will be too high to tolerate, too high to bear, too high to withstand. Okay, so that's why VMO is indicates the maximum calibrated airspeed at which the loads imposed by dynamic pressure on aircraft is acceptable. If you cross that calibrated airspeed, the loads additional dynamic pressure will be generated, and that will be harmful, or that will be too harmful for your aircraft. The loads that it imposes on your fuselage structure, etc. So VMO indicates that speed. Now let's talk about MMO. What is MMO? MMO is maximum operating Mach number. Maximum Mach number. Now what happens when when your aircraft, which is not when your aircraft achieves the speed of sound, that is called Mach 1 speed. Okay, when your aircraft achieves speed of sound, a shock wave will be created, a shock wave will develop around your aircraft. So let's say this is your aircraft. There will be a development of shock wave around it. So the place where Mach 1 is achieved first, over there you will see the presence of a shock wave. Now what are the side effects of shock waves? Shock waves increases drag, tremendous drag increase happens. Now, if your aircraft is not designed for such high speeds, especially Mach 1, Mach 2 speed of sounds, so this development of shock wave will be harmful for your aircraft. What will happen? Your aircraft drag will increase, and all of a sudden the nose of your aircraft will pitch down, and you will start diving towards the ground. Okay, you will start diving. So that is a very extreme position. You start diving towards the ground, so it is very unsafe. So this is what happens with your when you achieve the speed of sound and your aircraft is not designed for those high speeds. Yes, again, when you cross this Mach 1 speed of sound, let's say your aircraft is designed for speed of sound or high speeds, you cross this Mach 1 speed of sound and you achieve excessive speeds more than Mach 1. As a result of that, what will happen is that again more pressure or more loads will be imposed on your aircraft, drag will further increase, and vibration of control surfaces will happen. This vibration of control surfaces is very similar to the vibration or to the lightness of controls that we feel when we are flying a Cessna 172 and performing a stall maneuver. So the ineffectiveness of the control columns or the control wheel, the control surfaces, or the vibration that we feel just before hitting the stall or achieving the stall speed is what is experienced similarly in the same situation when you cross the Mach 1 speed. Okay. And that's why this VMMO represents that maximum Mach number beyond which you cannot fly your aircraft. If you do so, you will experience this ineffectiveness of control surfaces. Your aircraft will vibrate, the control surfaces will start vibrating. Why? Mainly because the boundary layer is nothing but the closest air layer to the wing surface. This boundary layer starts separating from the wing surface. It starts getting turbulent, and that creates this buffeting or vibrating feel, right? So MMO represents that speed. So I'm writing here MMO is the maximum Mach speed beyond which you must not fly in order to prevent development of shock waves and separation of boundary layer from the wings. Right? Now, between VMO and MMO, when does VMO apply? When does MMO apply? So remember, VMO, say this is your speed axis, this is your altitude axis. Now VMO, which is nothing but your calibrated airspeed, like I said, in order to maintain the same calibrated airspeed at higher altitudes, your dynamic pressure must increase 500, 600, 700, 800. So VMO, which is a constant calibrated airspeed, maximum calibrated airspeed, will be represented by same constant line. Okay, calibrated airspeed VMO. But maximum operating Mach number will be represented by a higher speed like this. Like this. So the place where they both intersect, that altitude, at that altitude, VMO will be equal to MMO. VMO will be equal to MMO. And at altitudes below this point, where VMO equals to MMO, what will happen is that your you will be limited or restricted by VMO. So at lower altitudes, you will be restricted or limited by VMO, calibrated airspeed. At altitudes above that, you will be limited limited by MMO, maximum operating Mach number. Okay, so at high altitudes MMO, at lower altitudes VMO. So this is the theory. Now you are descending. Okay, you are descending to lower altitudes. So from a very high level, it's written here, from a very high flight level. So first, when you are descending from higher levels to lower levels, you will be first restricted or limited by MMO. You will be restricted by MMO. Then after certain altitude, below certain altitude, after crossing that altitude, you will be limited by VMO. You will be limited by VMO. So initially at high altitudes, you will be limited by MMO, and after that you will be limited by VMO below a certain flight level. So option C. Okay. Next, in a standard atmosphere, sea level, the calibrated airspeed is equal to TAS lower than TAS independent of TAS. So correct answer is option Bravo. Your pressure instruments, airspeed indicator, altimeter, VSI, they are all designed to be operated in standard ISA conditions. Unfortunately, we do not have standard ISA conditions in our day-to-day lives. So that's why the calibrated airspeed or the speed shown by your airspeed indicator will be seldom equal to the true airspeed of your aircraft. You may be flying at 500 knots true airspeed, but the calibrated airspeed shown to you might be equal to 400 knots, 300 knots, anything less than 500 knots. Now, this will happen if you're flying at high altitudes where pressure in atmosphere is lower than pressure at mean sea level or lower altitudes. So this is always possible, but when you are actually flying in strict ISA conditions, when the conditions at sea level or at any other altitude is equal to the pressure, is equal to temperature, other conditions specified by ISA atmosphere, in that case, the calibrated airspeed shown by your airspeed indicator will be actually equal to the true airspeed that you are flying your aircraft. So only in ISA conditions the difference between them will be zero. In warmer than ISA conditions, in colder than ISA conditions, the ISA conditions which are in conditions of atmosphere which are worse than ISA in terms of pressure, humidity, better than ISA in terms of pressure and humidity, you will have differences between the calibrated airspeed shown to you and actual true airspeed that you are flying your aircraft. Similarly, you encounter differences between the altitude shown by a altimeter, which is indicated altitude, and the actual true altitude you are at. So I have covered this in detail in my altimeter errors video. You can find that in the playlist of altimeter meteorology. And I have also solved questions of Oxford altimetry back questions. So you can find those lectures in that playlist. So similarly, your airspeed indicator is subject to this errors, where the indicated airspeed will be different from true speed. But in standard atmosphere and ISA conditions, sea level, they both will be equal. VLO is the maximum what? Maximum speed at which the landing gear can be operated with safety, flight speed with landing gear down, speed with flaps extended in a given position. So VLO is the speed at which landing gear can be operated. Now let's say you're coming down for landing. At some point of time, you will make a decision to extend your landing gear. That means to extend your landing gear means to use your landing gear in order for landing. To do that or to achieve that, you will have to release your landing gear, the main wheels, the nose wheels from the inside of your aircraft, that is from the belly of your aircraft, and the landing gear will fall down. Okay, so this is called operating landing gear. After takeoff, you will have to retract your landing gear or you will have to put back the landing gear in the belly of your aircraft so that the aircraft structure becomes streamlined and the drag is reduced, the parasite drag is reduced, correct? So this is called retracting of landing gear, which happens after takeoff or after go around or after miss approach. Extension of landing gear happens during the landing phase of your flight when you are going to extend your landing gear. So this extension of landing gear, retraction of landing gear together are called operation of landing gear. Now this operation of landing gear means both extension and retraction. So it is the VLO stands for operation, which is the maximum speed at which you can operate your landing gear, whether that is for extension or retraction. Flight speed, then after retracting your landing gear, let's say you are coming down for landing, you retract your landing gear and then you're going to fly your aircraft with landing gear extend your landing gear. So after that you're going to fly your aircraft with landing gear extended, meaning the landing gear will be hanging down from the belly of your aircraft, and you're going to fly that aeroplane like that in that position. So that speed is called VLE, Lima Echo. So landing gear extension speed. That means the maximum speed at which you can fly your aircraft with landing gear extended, landing gear in the out position. Okay. So that is flight speed with landing gear down is VLE. Okay, the speed at which the maximum speed after you have extended your landing gear and you are going to fly your aircraft with that landing gear maintained downward position. Walk meter indications vary with airspeed and temperature, vary with airspeed only, vary with temperature. So correct answer is option Bravo. Walk meter indications are nothing but dynamic pressure divided by static pressure. Okay, so they are independent of temperature, they only depend on or They depend on airspeed. How will Mach meter indication respond if aircraft passes through a cold front, meaning you're passing through a cold atmospheric layer and you're flying at constant calibrated airspeed and constant altitude. So will the Mach meter indication or the Mach meter shown to you, Mach number shown to you, increase, decrease, or it will stay constant? So let's consider this scenario. You're flying from a warm atmospheric layer, warm air mass, into a cold front, that is cold air mass. Yes. Okay, so you're flying from warm layer to into a cold atmosphere layer. So initially your aircraft is in the warm atmospheric layer at same altitude, let's say 5,000 feet. It doesn't change its altitude. It flies straight and level. It enters a new air mass which is colder, right? So let's write it. Calibrated airspeed is constant. So let's take calibrated airspeed 200 knots. Calibrated airspeed 200 knots. Altitude, pressure altitude 5,000 feet. Pressure altitude 5,000 feet. So you are maintaining straight and level flight. Now the temperature in the warm atmospheric layer is 30 degrees Celsius. The temperature in the cold atmospheric layer is 20 degrees Celsius. Right? So now let's find true airspeed. True airspeed in warm atmospheric layer, true airspeed in cold atmosphere layer. And then we will find the Mach number. So using CX3 over here, speed. So outside air temperature in terms of degrees Celsius, warm temperature 30, calibrated airspeed 200 knots, altitude 5,000 feet. 100 knots, 5,000 feet, outside temperature 30. So in that case, your TAS is 224 knots. Mach number is 0.331. 0.331 and TAS is 224. Now let's calculate for cold air mass. Same values, only the temperature will be 20 degrees Celsius. So pressure altitude 5,000 feet, speed 200, outside temperature 20 degrees Celsius. So TAS is 220.66, approximately 221. Mach number is 0.331 and TAS is 221. So what happens? When you fly from a warm air mass into a cold air mass, your true airspeed decreases. 224 becomes 221. But your Mach number remains the same, 0.331, 0.331. Why is that? Another explanation, another way of looking at it is this. Mach number equals to your true airspeed divided by local speed of sound. Now true airspeed is divided by local speed of sound 39.17 square root of temperature in Kelvin. So Mach number is directly proportional to TAS and inversely proportional to local speed of sound. Right? So what happens is in warm air mass, your TAS increases. TAS is 224 and local speed of sound will be proportional to 30 degrees Celsius. And in cold air mass, what happens? Again, your local speed of sound will be proportional to temperature, so 20 degrees Celsius. If you put that in this formula, you can get your Mach number. So using this manual formula also, you can find the approximately same Mach number for two different air masses. So correct answer is option Charlie. Next. The building principle of a gyroscope, the best efficiency is obtained through the concentration of mass close to the axis with a low rotation speed, on the periphery with a high speed, close to the axis with a high speed. So correct answer is on the periphery, on the boundary and high rotation speed. So concentration of mass must happen on the edges and high speed. A standby horizon or emergency attitude indicator only works if there is a complete electricity failure, contains its own separate gyro, is automatically connected to the primary vertical gyro if the alternator fails. Option Bravo. Since it's a standby horizon or emergency instrument equipment, it must have its own independent power supply. That's why it contains its own separate gyro. It's not connected to the original system. It has its own separate setup so that if the original system fails, this setup or this separate gyro will work on its own, right? Question number 68. A turn indicator is built around a gyroscope with 1 degree freedom, 3 degree freedom, 2 degree freedom. So answer is 1 degree freedom. Indication on a DGI are subject to errors. That one of them is rotation of the earth, yes. Aeroplanes travel over the earth. Lateral and transversal bank angles, yes. Mechanical defects, yes. So 1, 2, 3, 5. Option Bravo is the correct one. When turning through 270 at a constant bank angle and pitch attitude, what will a classic artificial horizon indicate? Too much nose up, too little bank, too much nose up, too much bank angle, too little nose up, too little bank angle. So the correct answer here will be too much nose up, and it should be too much nose up and too little bank angle. If I'm not mistaken, too much nose up and too little bank angle. Too much nose up, too much, okay, too much nose up, too much bank angle. So for that, you will have to remember turning through 90 under reading of bank angle happens, pitch error indicates a false indication of climb. 180 turn, correct bank angle is shown, a false climb indication is given. Turn through 270 overreading of bank angle happens and false indication of a climb. Turning through 360 correct bank angle and correct pitch angle, right? So the correct answer here will be option Bravo. 270 turn, too much nose up, false climb indication and false bank angle indication, overreading of bank angle. So that's it. So this concludes our lecture. I hope you have understood all the 10 questions I have solved in this video lecture, particularly the question number 1 and the mock number question. Okay. So I wish you all the best. Do watch other video lectures in which you will find similar questions to this uh, particular questions we solved just now. And if you have any doubts, questions, let me know in the comment box. Subscribe to this channel if you haven't yet, and share this video lecture with your friends who are also preparing for various exams like CPL, ATPL, airline. They will definitely find this useful. I'll see you in the next video lecture, and don't miss that.